I'm using a mic for that, but I'm just going to project for you. Can you hear me? All right, great. I'm Nathan Howe. I'm Associate Professor at Kansas State University, the College of Architecture, Planning, and Design. I want to thank you all. I know we're having this kind of amazing Indian summer day right now, and to choose to be in a black box as opposed to out there is, well, I want to thank you for coming. The other people I want to thank is the sponsors for this lecture. We have the architecture department is sponsoring as on top of HOK, the firm, the architecture firm. They're also sponsoring this. They sponsored my studio. It's a fifth-year studio looking at urban renewal issues. But part of that, we thought it was appropriate to also use the funds to get a guest speaker in, and so that the college gets to appreciate this sponsorship as well as my studio. And so I want to talk a little bit about Nathan Miller before I give him the mic. I met Nathan probably, I think it was about 12 years ago. I was teaching at the University of Nebraska at Lincoln, and he was a third-year student there in Patricia Mergado's studio. And I remember it quite well because Patricia came to me right before the review and said, I want you to review Nathan's project. I wasn't going to see the entire studio's work, but she wanted to make sure that I saw Nathan's projects. She said he's exceptional. He's really kind of above and beyond what the rest of the studio is performing. I said, and she wanted him to take me the following year. I said, sure. Kind of wondering how good this guy could really be. Well, I reviewed his project, and Patricia did not oversell it. The sophistication of the project was well outstripped kind of his peers. And the next year when I had him in fourth-year studio, he continued to perform. In fact, I was lucky enough that year in fourth-year studio to teach also what turned out to be his wife eventually, Lisa Satter, now Lisa Miller. So I got to meet both these individuals. From there, Nathan and I kind of met up kind of every couple of years or so at different events, conferences, sometimes trips that we were making out to where he was living. And I got to catch up. And after graduation, Nathan went to MBBJ out of LA. And from there, you got to understand that would have been about 10 years ago. The computer before that really had been only about design efficiencies in the architecture world and visualization in the architecture world. It hadn't really become a kind of essential design tool outside of those two things, efficiency and visualization. There really hadn't found a way of capturing all this processing power to actually be kind of extraordinarily important to our process. And Nathan was at the forefront of that when I met up with him at MBBJ. He essentially, right out of school, became an essential part of their computational arm. In fact, you might say that he was that computational arm for MBBJ. And I found out also that he was instrumental in becoming part of a kind of a competition sector of MBBJ, and found himself 1, 2, 3 years out of school, kind of leading, being a leader at that firm, a global firm, which I find extraordinary. The next time I met up with Nathan was, he was working for Case. And Case, if you didn't know it, at that time was this firm that was looking at creating tools for architecture firms to use. So they were not only kind of becoming a part of architecture's kind of new tool set, as it were. So anything that the firms didn't kind of got over their heads on, they would step in and be able to help them with that. And during all that time, Nathan had started a blog called Proving Ground. And in that, he started to create a window that we could all look into, a little portal, of all these experiments. And so he created a laboratory for himself. I'm sure Lisa lost many nights where he was probably working at the computer instead of actually going to bed. Because all these things, it's like, where do you have time for this? I don't think he gave me a good response to that. But he created a laboratory. That Proving Ground became a way, of open source way, for him to show kind of his own kind of inquisition or inquisitive nature into what is possible with connecting geometry from one source to the next, how to collect data and make that kind of a critical moment within the design process. And all these little widgets started to kind of appear. And that leads us to, I think, the present day, where now Proving Ground, he's left Case, he's created his own company, it's Proving Ground, and what I find remarkable about Nathan Miller is that he's not only a great designer, but now he's a designer of tools. So the next, you guys are going to graduate in the next few years, and he's really giving you, or the idea is that you will have a whole new tool set to use as a design and lead your practice. But perhaps he's kind of showing you at least another path that you could lead the practice in general. So without further ado, I will turn this over, and I'd like you to all to help me thanking Nathan Miller for coming.
Thank you, Nathan. Well, I think I can cut out the first third of my presentation. I appreciate that introduction. That was great. And thanks for reminding me where we first met. That was, wow, it feels like ages ago. Nathan has been a great friend and mentor to me since I started down this crazy path of architecture and buildings and construction. I should also note that there's not only is one member of my family, Lisa, here, as he mentioned, I also have a little kid. So if there's a little kid, 2-year-old, that starts running across and wants to talk to Daddy right now, it's okay. It's okay. My talk, in many ways, is going to be a reflection on what it means to work in the industry as we know it today, and hopefully starts to chart out a couple of ideas on where I think it's going to go. And in many ways, the work that I do has always come in response to one phrase that has continued, for lack of a better term, to piss me off as a professional ever since I got into it, because that is the way we've always done it. It's the response that I get in this very risk-adverse industry, why not to do something rather than to pursue something. And much of my work, when we start talking about data, computation, and technology, takes a very close look at this. And so I kind of wanted to start off the lecture by talking about how we've always done it. This is a chart that looks at productivity in manufacturing versus construction from 1994 to 2012. This is published by McKinsey. There are numerous charts and studies that look very similar to this when it comes to how we start to look at our effectiveness as an industry. What does it mean to become more productive, to be more efficient, to be more innovative? And what you see is a trend line that starts to tell a very interesting story about our industry, not just architecture, but the industry in general. Anyone operating in construction. Manufacturing, of course, we see advances and adoptions of technology and new processes. This is not just a technological question. That is, when you start to measure it based on this very coarse metric of productivity, has grown. We are seeing more value added per worker. Construction has remained flat. Why is that? Similar line of research. I like to scare people when I start talking about this stuff. It starts to talk about what it means to be operating in this industry right now. 98% of mega projects suffering cost overruns of more than 30%, 77% are at least 40% late. And an aspect of this that I think really starts to speak to what it means to become better. And something that I would encourage any practitioner. How many folks in here practice? Are practicing? There's the one, my wife, Jay. Less than 1% of revenues go towards R&D efforts in construction, compared with 3% in other industries. So a lot of my kind of work, stems from kind of this idea that we have a process improvement problem. We have this opportunity, even with all the information at our disposal, all the data that we can access, all the technology that we have at our fingertips. These kinds of stories begin to paint a very different picture about innovation. And I'm going to start kind of talking about my own personal experience with a bit of an origin story. I'm a comic book fan. I like to think about things in terms of origin story. I think Nathan did a better job of telling my origin story than I'm going to be able to do. But I'm going to actually start with a project. And apologies to the designers in the room, because this is actually going to be one of the few actual buildings I'm going to show. A lot of this is going to be much more about process. It's going to be much more about tools, and adjacent to that are going to be buildings, of course. But this is really where I started to get really into this stuff about computation. I always liked the computer from a rendering perspective. I always, as Nathan alluded to, this idea of being more efficient as a designer was something I was always kind of interested in. I used the computer as a tool to help me think through design. This project started to shift my thinking a little bit and started to look in terms of looking at different aspects of technology as it relates to design. This is the Hangzhou Stadium. It was done while I was at MBBJ. A little background on this one. Nathan mentioned I was heavily involved in a lot of competitions while in Los Angeles. This one was I like to joke this was an accident. This wasn't meant to be the story, one of the stories that I would think about telling 5 years later. There was a slow period in the Los Angeles office. There were about 2 weeks where I was free. I was there wasn't a lot of work. We're waiting for new projects to start up, and there's this competition that came in the door. They were on the fence on taking it or not for a 80,000 seat stadium in Hangzhou, China. And they're like, oh well, Nate's available. Let's put him on it. And there were a couple of other folks that kind of teamed up on this thing as well. We put our heads together for about 2 weeks, generated some schemes. The partner architect we were working with in China flew over. She sat right next to me, which was very kind of annoying. I'm sitting there trying to model some stuff, and she's like right here. What are you making? And sure enough, we come up with this scheme of this kind of replicating, kind of pedal-like geometry. It wasn't really ever meant to be sort of flowery in metaphor. It just happened to be an interesting pattern that we were working with at that time. And the team became very enamored by it. We're like, okay, let's submit this and see what happens. It ends up winning and moving forward. And it placed me as a 1 year out of school designer in the role of sort of this lead design on an 80,000 seat project in China, because at a certain point, the question then became, how are we actually going to do this? And part of the logic and the underlying technology that allowed us to generate it became, in many ways, the driver and the main production engine for how we were going to deliver it. This is Grasshopper. This is like one of the very, very early versions of Grasshopper. Any students using Grasshopper in this group? You guys have it easy. This was tough. There were, you could only really do anything sophisticated if you were going to start to script with it. It was very challenging to get anything to happen out of this software unless you were actually going to start digging into the code. So it started to force me to learn programming at the same time. But I became very fascinated by what it meant to start to think about not only this, aesthetics, experience, but also think about this, process, algorithm, computation in parallel. There's also something very interesting happening under the hood that really wasn't exposed in any kind of direct way through the computer screen. And that was this very messy process of how, in this case, 3 collaborators were working together. Local architect in China, their structural engineer, and MBBJ is the international design team. Everything in between this kind of mess of spaghetti represents the data workflow that was occurring under the hood that allowed this team to collaborate. You had file formats being transferred between different participants. You had data connections starting to emerge between the structural engineer and the main design algorithm. You have connections between AutoCAD and Revit occurring that's allowing the documentation process to happen. Bye, baby. I was waiting to see how long it would take before he got tired of listening to Dad. But you have all these connections being made, and so you have this kind of very unmanaged flow of data that's allowing for this collaboration to happen. And so I became very interested in how this process can start to kind of evolve, and which would allow us to do the next project even better, and then the next project, and eventually, as Nathan indicated, I kind of made that in many ways an instrumental part of my career. This is a more recent project of the construction progress. I saw a video of it recently, which was I don't think it's been made public yet, but there's a whole other site component to it. But interesting to start to see the overlay at a certain point of being able to take the model and apply it on top of the built one. I don't have it in this talk. I have a series of older talks that actually looks at the centerline structural model relative to the structural design on this, and actually showing that even across the ocean and operating within processes that are beyond our control, we actually end up with a high degree of accuracy because of the kind of feedback loops that were present. This story started to kind of shift my path a little bit in the firm. I started becoming perhaps less a traditional designer, and started to look at kind of other systems, other ways with which we could start to take what was done on one project and apply it to many. This is a demo reel of various computational tools that were built over the span of 2 years following that particular project. You have algorithms that are looking at form. You have analytical algorithms that are looking at sightline quality in stadiums, tools for rapid massing studies within kind of very fast-paced master planning projects, circulation tools, programming tools, getting into the structural side of things. These start to paint a story of how the story of a project doesn't necessarily need to be a one-off thing. We can start to think about design processes as being rapidly deployable tools that can help us begin to think through problems, design challenges, and things that we're seeing on a day-to-day basis in a different way, and capitalize on those efficiencies as we go. Where it's less about reinventing the wheel every single time. That's the one thing, in addition to the quote I had at the beginning, because that's the way we've always done it. The other thing that I really dislike is the idea of well, every building's a one-off, so therefore our process is always going to be a one-off. That's absolutely false. So that brings me to Proving Ground. There's a whole chapter in there where I was at Case. I kind of went to the dark side and became a consultant, working in the world of building information modeling and technology and algorithms. Within the last year, have started up my own venture, which is Proving Ground. And our aim is to bring together a couple of ideas. There's this idea of working with architects, designers, engineers, and manufacturers to be strategic with their thinking about data and technology and workflow, working at that kind of 30,000-foot view on what it means to operate as an organization within our industry today relative to these new trends that we're seeing. And then there's an aspect of what we do which is about solutions, making solutions for clients, building tools, building algorithms, and building components that can make that strategy actionable. Everything we do is not possible without our clients. This is just, I guess, an interesting cross-section of who we're working with right now. Not only are you seeing architects like Adrian Smith and Gordon Gill, Gensler, HDR, Populous, there are manufacturers. Nucor supplies 90% of the steel, almost 90% of the steel to North America. They do make steel trusses. So we've been doing a little work with them on looking at what the data workflows mean by rapidly consuming data from engineers and making it actionable within their shop floor. Ceilings Plus, acoustic ceiling panel maker in Los Angeles. Flux, a software company. We're interested in partnering with people that are interested in making use of data in the world of building. So what does it mean to be data-driven? I guess the core of what we do is to help businesses, help projects, help architecture become more data-driven. We believe that there is an element of, there's a high level of value. There is an element where data can help us be more performative with the work that we're doing. And in many ways, our namesake, Proving Ground, comes from this idea of proof and data becoming kind of an instrumental part of providing proof on certain design problems. To be data-driven is about providing insight. This is the scariest slide I'm going to show you today, I promise. This is horrifying. This is the same data. Before, what you were seeing were numbers, very hard to intuit, trends, insight. This is that same data set visualized using vectors, colors, and geolocation. So that was the ASHRAE data set looking at weather data from across the world. And we're taking that information and giving it giving it a sense, giving it a representation that allows us to intuit trends, gain insight into different aspects of itself such that you can begin to make decisions and identify possibilities. And that's really what data-driven design is for us. It's about being able to take this vast amount of stuff that we have, use techniques to mine for it, and then provide interfaces with which designers, engineers, and manufacturers can begin to interact with it. Very different data set. This is energy modeling. This is a early stage analysis of a hospital by Centera Health. This was done with HDR, very quick study, looking at what it would mean to add on 3 new zones to the hospital. And not only are we looking at it in 3D, but interfaces like this, which allows for a degree of interaction to occur between what we're seeing as built form or proposed built form, and then the underlying performance of that built form represented through an interactive dashboard. I've grown to appreciate the pie chart as much as the kind of 3-dimensional view of a building, both when they kind of begin to operate with each other, start to kind of provide us with a different type of way of working, where our decisions and the way we work can have this feedback with underlying performance factors. This is a 3-dimensional model. This is Rhino. You're seeing mouse interacting with floor plates, slicing up a building, assigning it to different layers. Everything that you would normally do as a designer happening in a very intuitive way, but then overlaid on top of this an interactive dashboard that's giving you rapid feedback about cost, about programmatic mix, ratios, sections and elevations occurring simultaneously as you're working. Think about the waste that goes into developing a building scheme, only to have then this auxiliary process where you're actually going through and like clicking on floors and adding things up. This is providing you not only with that, but much more insight into the process as you're working. So for us to be able to deliver on this type of vision, to kind of seed businesses with this way of thinking that goes beyond a project here or a project there, we have very specific things that we do with clients and also recommend. And when I say clients, I mean other architects. I mean other engineers. I don't mean necessarily building owners, although we have done some work with owners. The first is this idea of creating a roadmap. I like to operate at 30,000 feet as well as write code, which I think maybe provides me with a very different perspective than most. Has anyone seen this diagram? The hype cycle by Gartner? This is a fun, I find this one hilarious, especially the terminology. Gartner is they're a research company. They publish this every year when it comes to how they're positioning various technology trends against each other in the business place. Internet of Things, big data, VR, AR, drones. Their basic premise is that every piece of technology follows the same type of pattern or same type of cycle. You have a trigger, a new technology is introduced in the marketplace. Part of what we do is help kind of businesses identify what those triggers may be, or what are we actually seeing as triggers today. Immediately after new technology is introduced, you see this very sharp rise. This is all very kind of intuitive in many ways. There's like not necessarily numbers to go through what this actually means. It's sort of diagrammatic. Up to the peak of inflated expectations. This is going to change everything. We want this now. This is going to transform the way we work, and it's going to transform it overnight. I want my entire house wired up with sensors. I want every building that we're going to design for the next, over the next year to be hooked up with monitors and performance systems. Everyone gets really excited about this. And then what people quickly realize is that there is then an equally sharp decline, if we're not careful, to the trough of disillusionment, realizing it didn't quite work out the way we thought it was going to. Now what do? Do we let this technology die off and we don't adopt it? Or do we start to look for what we call the slope of enlightenment? Finally, we can start to find these ways with which we can take technology from sort of the peak of inflated expectations up the slope of enlightenment to where we have the plateau of productivity. It's very, very inspiring terminology. The idea of then finally taking what the potentials of this technology are for business and actually making them immediately productive in our workflow. We see BIM going through this cycle. We're now seeing AR and VR going through this cycle in a very big way this year. The amount of investment, capital investment in AR and VR technology, especially as it relates to construction, is astronomical at the moment. So what we like to do is think about and work within these kinds of diagrams within this context and help organizations build their roadmap. We're going to, we've worked with Gensler on this. We've worked with co-architects. They're out of Los Angeles, a Canadian company called Dialogue, HDR, to define roadmaps for data and technology focused on innovation and relative positioning to other places in the market, right? What are your peers doing? What's coming into the marketplace right now that we should be aware of that would allow us to leapfrog in certain areas? Where can we be early adopters versus laggards when it comes to these tools and frameworks? So we work with companies to think through this. It results in 8.5 by 11 sheets of paper in a lot of cases. Not too inspiring, but it sets the framework with which we can start to innovate. We look at knowledge. One of the interesting things that I've found in architectural practices today is that no one knows what they know internally, right? If you want to know who your top performers are with BIM, do you know that for sure? Are you guessing? Is it because it was on their resume? You have a project that's coming up that's going to require a ramp up of staff. Are all staff treated equal, or do we start to position people in different roles and in different cross-functional relationships? This was a study that we did at HDR. They're a major client and a very frequent collaborator of ours, where we looked at over 460 staff. We did a knowledge assessment in terms of levels of confidence. We had a questionnaire that looked at BIM understanding. This was across 25 offices and 5 countries. And we actually created a full dashboard and analytics platform that would allow them to look at where the potholes were, where the barriers were for adoption, where were their strengths and where were their weaknesses, such that when they say, okay, we need training, well, you know exactly what that means. It's not going to be everyone's going to get the same 5-day Revit training. Well, maybe your project managers need training in understanding contracts relative to data. And maybe your junior staff needs more targeted training around analysis because they're not equipped yet to deal with some of the demands that their clients are being presented with. This provides that insight. So we have this idea of road mapping, and then the question becomes, well, where are we going to get all our data? We have a lot of it. We have APIs that allow us to connect right into weather stations. We can use our building information models in Revit to extract all sorts of data. What's going to be right for us? So a lot of what this roadmap does is help position also data sources such that you're able to focus and align your vision as a company to data sources that will be meaningful to help companies project their vision and build upon their ambition and their vision as an architecture practice or as a manufacturer. So we've built quite a number of tools that just look at the idea of mining data from different avenues. There's Revit as we kind of know it as this production tool, right, which is going to help us generate plans and sections and documents at accelerated pace and breakneck speed, ideally, when compared to other kind of means of work, methods of working. But there's also this data layer to the program that can provide immense insight and into trends that exist across your markets. So what you're seeing here is mining of that data from a Revit model and pushing it into a database. We're not trained to understand databases, but maybe we should be, because in many ways it is just as essential of a medium and a way to kind of understand a project now as perhaps a plan or a section is. Being able to query a database, get to data about your project that you need to understand assets as they're being tracked from your desk as a designer to the site, to installation. All of this stuff is technically possible. We can also look into and find perhaps trends that we weren't aware of. This is anyone heard of Tableau? Power BI? Business intelligence tools. If you're working for a firm, odds are your accountants are using them. People that are analyzing social networks are using them. People that are wanting to understand big data and trends are using them. This is that technology. This is Tableau. It's used, it's a business intelligence tool. It allows you to tap into multiple data sources and then begin to pull apart that data into rapid visualizations. This is Gephi. This is a scientific tool. It's open source. It's completely free. This is looking at relationships between elements of a program visualized in the form of a graph. People use this to understand what the various connections are on Facebook or what it means to have tweets and retweets on Twitter applied to the world of building. This is a three-dimensional graph looking at departmental relationships in a building, looking at things by level, by department, and finally down by room. But a different way of looking at kind of an organization of space. I want to pause this, if I can. Did I do it? I did. This is a new form of deliverable. We just worked with HDR on this one. This is They do, as part of their architectural practice now, they're heavily invested in consulting and working with clients to help right-size programs. This is for a series of clinics, 15 clinics at the University of Utah. What they're able to do is take the client's records of number of patients seen over the course of the last 10 years, what the demand has been on their clinical facilities in their project. They're able to look at what things like patient wait time has been, and then they've created a model. They've created a simulation model that then allows them to project for the next 10 years where that projected growth will take a company and an organization. We're taking that simulation data and we're developing, and we have created a usable tool that is client-facing. This is something that the client, in this case the owner, is able to begin to interact with, to take the simulated results and then begin to make decisions on their facility. If we were to organize our building, organize our new clinic with organization type A versus organization type B, what impact does that have on patient wait time? Do I need fewer or more clinics based on that decision, clinic spaces? Do I need to have more doctors on staff? They're then able to use this as a tool to then inform those business decisions, which could save their client money, but then immediately begin to inform and provide clarity and insight into what it means to go into schematic design based on this information. We're able to create interfaces that scrub this information in different ways. We can start to isolate different criteria. There are thousands of runs stored in this database. Each of these lines down here, each of those lines that you're seeing up there is one possible scenario. And so within this kind of interface, within this dashboard, they're able to start to search and seek and find options and alternatives for their operations of their facility that will be beneficial or kind of meet their expectations as clients. We have the data. How do we make the connections? How do we design the workflow? I love workflow design. Workflow design is in many ways the core of the service that we provide to clients. We build tools, yes, we build data visualizations and dashboards, but under the hood, the real technical rigor comes down to how the workflows are being designed. You saw the first sort of spaghetti diagram of file formats and information exchange points occurring. What we're talking about is making sense of that into repeatable processes that can be deployed by design teams such that they can focus on the thing that they want to focus on, which is good design, and into the background can go this idea of workflow. It can become invisible such that it's not the forefront and the major pain point that it often is in projects. A couple of snapshots of what I mean by workflow design. These are cross-functional charts that look at the relationship of data between various platforms, and then user scenarios that would guide a user from one platform to another based on what they want to do. I'm a firm believer in picking the right tool for the job. If I'm wanting fluid parametric exploration, I'm not going to use Revit for that. I'm going to use Grasshopper. If I want to visualize data in a very fast and robust way, I'm probably going to use Excel. What is the workflow for moving this information? And that's what we're here to define. So this is moving Revit data into Excel. This is moving Rhino into Revit for a facade panel, which can yield some very, very interesting results. This is a project, I can't talk about the specifics of it, but this was something that we were involved in, involved a grand stair. You can start to see that there was a paneling system designed and developed that kind of wrapped this grand stair, all in Rhino. Rhino is a very good tool for dealing with that sculptural geometry and building it up. The workflow here was about how can we actually begin to take that design geometry and make it reusable within a building information platform. So we're taking that data, taking the underlying point relationships, and instead of telling the designer, okay, now go rebuild it inside of Revit, automate its construction. Make it so that you can actually use that information to drive the next step of your documentation process and production process. And it doesn't stop there. This can go well downstream. This is a project and a prototype we built for Ceilings Plus. They're manufactured. They do acoustic ceiling panels. We're working with Zaha Hadid, UN Studio, a lot of complex stuff. We wanted to take the same set of principles and design the pipeline that would allow design geometry to connect right into a production system like Autodesk Inventor. So you're seeing the automated rebuild of design geometry as bent sheet metal inside of Autodesk Inventor, such that they can then feed that right downstream into their shop floor. A lot of waste is typically packed away in this, which starts to allow us to opens the question of, if we're going to rethink the workflow, are we not also rethinking the supply chain? And I think that's one of the things that we're going to see very, very soon, if we're not seeing it already, is sort of the push of what data-driven really means for the supply chain of design to manufacturing. This is a little bit different. This is a workflow that looks at existing conditions, and not only taking existing conditions, but linking them into a building information model in a novel way. Point clouds are really interesting. They provide a high level of accuracy to the idea of capturing existing conditions, but they're pretty unwieldy when it comes to actually producing usable geometry inside a BIM. So what you're seeing here is a custom interface that allows us to rapidly consume point clouds inside of Revit, but you're also seeing a process here with which we're taking the point clouds and constructing features for a historic restoration project, wherein we can identify every single brick that's captured in this point cloud. We can assign it an identifier. We can assign it an ID, load up different resolutions of each feature on the fly within Revit so the design team can start to work with it. So something as flat and as heavy as a point cloud can become a key part of the building information strategy. So you're starting to see the buildup of this with every element inside of Revit clicked, right? These walls are abstracted versions of what actually is an assembly of things. We're loading that on the fly from a custom database. I was at Chichen Itza 2 years ago, and anyone been to Chichen Itza? Yeah? Amazing. The tour guide took us by this pile of bricks sitting off the side. He's like, oh yeah, you see those chalk lines over there? That's how we're indexing all these bricks and going through this restoration process. I'm like, oh, I could solve this. I could fix this problem. That's kind of what we're after here. Intelligent ways of dealing with these ideas, because they are going to disassemble this building and eventually put it back together. So how are they going to do that? We make tools. Part of a lot of what you're seeing is leveraging tools as they exist on your desktop. Revit, AutoCAD, Microsoft Excel, Office 365. People ask me what my favorite design tool is. I say Office 365. People look at me really weird when I answer them with that. But built on top of this is this idea of making something, making tools, making workflows. In many ways, Proving Ground is a very specialized software development arm. I'm not a programmer by training, but I would say that 80% of what I do is write code now, write software that deals with these building problems. I'm also interested in software development and tool making from the standpoint of process. Agile ways of working that you find in software companies, I think point to a model that it would be very interesting to start seeing more designers start to adopt. This idea of Scrum, of agile process, lean process that allows for development and iterative cycles, as opposed to the big Gantt charts that point to these very rigid phases that never quite work out the way you think they're going to work out. Concept design, schematic design, design development, construction documents, construction administration. We know as designers that design is not a linear process. So what does it mean to start to think about, neither is software development, what does it start to mean to think about different ways of working that allows us to work in a nonlinear way, make money while doing it, and provide the best solutions to clients. And part of my interest in software development is actually looking at not only making tools, but the mechanisms with which tools get made at their foundation. This is kind of how we work when it comes to rapid iteration of tool making. We usually always start with this idea of a prototype. This idea of making something that's fast, cheap, can be readily disposed of if it fails. You hear the Silicon Valley motto, fail fast. That's really what prototyping is all about. It's also about vetting requirements early on as you possibly can, to make sure you're on the right track. Prototype can last 2 weeks, right, when compared to a multi-year software development project. But we can get to solutions very fast that provide even a fraction of the value that the full product might be able to make. But we're able to do that through a fast iteration. We're exploring. Then we operate on these kind of sprint models. Every 2 weeks, we're turning around an iteration of a product with our client. Next couple sprints might be about robust functionality, and then into improved stability as we work with them. Requirements are going to change. The context with which we're operating is going to change. They're going to see a feature. They're going to see an aspect of what we've made and determine that's not really what they wanted. We're going to need to change it up. And this allows us to vet that out. I had 3 interns on over the summer from the University of Nebraska. This is my pitch to all the students in the room. If you're interested in making tools over a summer, let me know. It's 8 weeks. We treated it as an R&D shop. We wanted to explore ideas that weren't necessarily client-driven, but we wanted to understand what it would mean to develop a process around a certain thing. We built out a cost model for a large project using this iteration over 2 weeks. We set out, okay, here's the technology stack. We want a live interactive dashboard with a building that can communicate cost variables and breakdowns, very similar to what I showed you, but have it be bundled up and packaged into a working prototype. We looked at solar analysis, line of sight in a facility, relaxation of surfaces. Each of these was a 2-week iteration of a computational problem. So we're making tools at a very breakneck speed. These are all open source if you're interested in digging into them. They're out there in the wild. But it becomes a way to kind of seed thinking within our workflow, and also seed thinking externally as well, because some of these have actually become real commissions. Some of them have actually come back and said, like, actually, we want what you've hinted at in this prototype. Let's build it together. Very interesting approach. So what does this stuff do? This is a project that's looking at blocking and stacking. It's a little bit of internal R&D. This was something that was built about in a week and a half by one of the interns from the University of Nebraska who had no Grasshopper experience prior to coming to work with us. I'm very proud of this. He learned Grasshopper and started doing very sophisticated stuff very, very fast. It looks at clustering of like programs into departments, packing them into confined spaces to look at different arrangements. We are setting out parameters with which this kind of blocking and stacking can occur and start to iterate on some very interesting forms as a result. But it's a tool that, again, allows us to think a little bit differently about a common process in the design world of design. And using algorithms, we're thinking through solutions a little bit differently. Ceilings Plus, kind of hinted at this a little bit. We not only did some strategic work, we also did some tool making with them. This is a set of tools that looks at their shop drawing process. They're 100% AutoCAD. They're sitting there and they're drafting up lines, pulling in their details. They engaged us because not only is the work coming in faster than they can do it, they're also dealing with much more complex problems than they've ever had to deal with. So this has required them to think about change in their organization such that manual process, wasted effort, repeatable things can actually become resolved. So we started building tools. This is using a combination of Grasshopper, Rhino, custom scripting, cool plugin called Human UI. Andrew Human made this thing. He's an MBBJ colleague. Or what we're doing here, something that would take them a couple of days is now being collapsed into a couple of minutes or a couple of hours because we're able to kind of go in, map out their workflow with them, think through what it meant for a design to come in and what it meant for them to actually produce shop drawings, identify areas of waste, and then start building tools around things that could be adopted. They worked on a huge Gensler project recently, and one of the outcomes of this, they actually did the sort of calculation time of what it meant for them to do what they would have done before and how they were doing it now. We saw a 40% reduction in time needed to actually execute the entire shop drawing process because of these targeted uses of technology in their business. There's probably no populists in Kansas City. Great guys. This is a tool that actually started at CASE, and then we did, and I was kind of one of the leads on that. We did 1.0 through CASE, and then one of our first commissions as Proving Ground was 2.0 of this. A sightline tool built into Revit and completely parametric. So we're using sightline calculations. We're tying it into what they know as being constructability constraints and requirements. I'm no stranger to building sightline tools. It was one of the very first parametric tools I built when I was kind of a designer and really starting to get into stuff. But we've taken it to a whole other level. Not only are we doing it 100% in Revit, but we're also marrying up 2D and 3D such that it becomes very easy now to begin to update a design and take it through documentation. Even down to things, this was a huge technical challenge. I don't know if you've ever placed stairs on a sloping building before. That thing was hard. Placing bombs, automating that kind of placement, building intelligent content that would allow them to kind of cycle through variations in that content and have very clean modeling as a result. It's all part of this toolkit. And then my favorite piece is coming up right here. I'm not even going to say anything. Every seat placed at the correct setback from these aisles, schedulable, quantifiable. You can swap them out with different types, and it tracks that relationship. If we go back all the way to that initial sight line, we can actually see that change populate its way the entire way through this sort of supply chain. I love the seat tool. Project management software. I never thought I'd build a piece of project management software before, but I happen to. I'm going to make a recommendation to anyone in this room that's trying to keep all their tasks straight. I highly recommend checking out Trello. It's a free service online. It's task management software. You can do anything from your grocery list to very complex projects and track multiple team members and what they're doing. Very popular in the world of software development. We have built an app that ties it right into where the work is being done, such that as you're doing tasks, as you're building up your model in 3D, either it's Rhino or Revit, it can sit in both. We've got a Navisworks and an Inventor version of this kind of popping up. Still very early stages in some ways. But you can start to say like, hey, I see a modeling issue, or hey, I see something that needs to get done. Let's actually create a card, let's set a due date to it, let's assign who's going to do it, and then push it out to a database that we can then track it with others. We can actually start to then see how these tasks begin to populate what is essentially a cloud-based tracking system of that stuff. It's all ending up in the cloud, and we can start to make sense of it to inform next steps on the process. Everything that I'm talking about also relies on people. Can anyone spot the difference in the makeup of these two workshop groups? On the left-hand side, you have senior executives of a 1,500-person architecture company sitting around a bunch of computers learning Grasshopper. Why are they doing that? It's interesting to me where we exist at a point in an industry where the folks that are running businesses have very little idea how the work is actually getting done. All right, there's a disconnect, there's a widening gap. Given the pace of technological change in our industry right now, there is a widening gap between what new students, what new professionals are going to be bringing to the table and what owners of businesses understand and know regularly. So what you're seeing here is a workshop not because they're going to start learning and using Grasshopper in their day-to-day work. They wanted to understand what were the tools that their staff are actually using and how can they then begin to make management decisions to help guide in the effective implementation of those tools. On the right-hand side, you see young professionals, new professionals coming in and learning the same software for a very different purpose. They're coming in to learn the tools such that they can do their work more effectively, such that they can grow as new professionals within their company. But you also see kind of a very different manner of learning emerge when it comes to these technologies. I just taught a couple of workshops in New York for a sizable company this last month. I've become increasingly critical on how we actually learn tools. I don't know that the best model is to have someone sitting in front of a room with a bunch of people around computers as being the best way of absorbing this stuff. I'm much more of a fan of this idea: hackathons, hacking, problem solving, kind of collective engagement around a common set of problems. Hackathons are interesting. They're 24 to 48 hours of intensive development and self-organization around certain problem sets. It involves bringing together and bringing to the table people that you know more than you in certain areas, and also bringing to the table things that you know you can provide certain expertise around. And then you are effectively locked in to making a minimum viable product in a very short period of time. This room got pretty stinky after about 24 hours, but people do these things and they learn very, very fast, and they have product to show for it at the end of the day. I'm very interested in not only hackathons as a way of spearheading research and development in organizations, but also as ways of spurring learning in a professional environment that will, at the end of the day, lend value. And I alluded to it earlier when I showed the tool. We need to couple our capabilities and our tools with processes that can match them. We need to be able to think not only about what we can do now that we could never do before with technology, but then how do our current processes adapt to allow us to make the best use of it. I would say that project management is an area that we're going to see transform quite a great deal in the very near future. I'm interested in this idea of what, in particular, Agile for building teams means. This is that same interface, Trello, and what you're seeing here from left to right are certain tasks make their way from kind of initial backlog to something that's an emergency, to something that's in development, testing, deployment, finally something that's complete. All something trackable. So where's all this stuff going? We can say as much as one, hey, it's great to have all this data, it's great to have all these tools and technology. I like outcomes. I'm always encouraging the businesses and organizations I work with to focus on outcomes. Don't do it just because, do it for a specific reason. I'm going to show you a couple of kind of tangibles that I've picked up. I think I'd like to have more of this stuff captured, but I think it starts to speak to a deeper problem that we're not tracking outcomes as an industry in the way that we could or should be. Part of the concession and one of the main assumptions about those studies that showed very early on about manufacturing versus construction, et cetera, is somewhat built on the fact that there's faulty data. A lot of that data had to be reverse engineered from multiple sources. We're not tracking things in the way that we could. But here are just a couple of examples. I'm coming back to the stadium because there were some really interesting things that we were able to track from the first concept through to the final iteration of the project that eventually got built, one of which was steel. We wanted to understand, I personally wanted to understand the impact if we were able to now go through 10, 20, 30, 40, 100, 1,000 iterations of a project, are we actually improving the design in a measurable way? If a structural engineer asks us to move one brace, what's the actual impact that it has on the overall project? We're able to measure the very first design relative to the very last design. And through this process of high iteration, we're reducing the structural steel consumption by 50%, right? From first iteration to last iteration. We also benchmarked it against other stadiums of similar size and sculptural techniques. So, I wouldn't say technology is purely the only thing that's responsible for this, but technology certainly enabled the iteration and the conversation to happen in a way where decisions that impacted this metric could come together. We did the same thing on this project. This involved calibrating a louver system for Snøhetta. And this was a headquarters that was in Norway. You kind of see there's these angle louvers, right? They started from a place that was very conceptual. They started from a place that was very artistic, but they know they had specific performance requirements to meet for this exterior solar shading system. And so we created a parametric model. We ran it through I think it was 200 iterations. We tested different angles. This thing was on a strange site, of course, and there's sort of a faceting that's happening. They wanted to understand where their space was to play. They also wanted to understand parameters that they could manipulate, where they could maintain conceptual consistency and rigor, but also have the rigor of having decisions that met these criteria. And through this process, we saw a 20% increase in the shading function of the overall system and a 60% reduction in structural weight from their original concept, right? Very powerful stuff. Very, very much an example of a firm that's very conceptual at the start of a project. They've got, they have an amazing aesthetic eye to things, and layered on top of that a process that allowed them to play within the rigor of data, and you have some pretty amazing outcomes. RTKL, 80% reduction in modeling time. We took the kind of tasks at hand. There were Rhino models, SketchUp models, all these different models that were in play. We looked at what the burn rate would have been on the project had some of the technologies we deployed and customized, had they not been in play. And we looked at comparable projects in their organization. We're able to go through and then benchmark it against this project. And with a well-designed workflow, we're seeing an 80% reduction in modeling time. Time that doesn't necessarily mean they go home early. These are designers after all. But it's time that's going back into making the project better, right? It's about taking the waste and putting it towards things that are going to lend value. Further thoughts, going to run out the clock here. The tools are on your desktop. Software is cheap. You already probably have it, right? You have Excel, you probably have Rhino, Grasshopper, SketchUp. These are common things. There's nothing here that I'm showing that is something that you can't procure, with the exception of being able to learn how to code, right? Learning how to code is increasingly cheap. There are many resources out there for you to learn, and a programming language isn't something you necessarily pay for. It's coming with your desktop. It's already sitting inside of your computer. So actually surfacing it, starting to work with it, it's right there. big organizations, any organization of any size, brings up the idea of technology roles and what that actually means. If you're able to find people that are passionate in your company, or you yourself are passionate about pursuing this kind of agenda in your work, this stuff pays off. The cost of a BIM manager can look at first glance, the average cost of BIM managers, especially in New York and Los Angeles, San Francisco, they're on the rise, and so people will look at the sticker price and shudder. But the amount of impact you can have on a process, this stuff ends up paying for itself. Coding know-how will only grow. I highly encourage anyone in this room that has any inkling to learn how to code to do it. The value, even just simple, basic automation, can take you to very new places, and very different places, and very valuable places. I failed my very first coding class. I was a terrible coder. It was like my freshman year in high school. I hated it. I didn't see any value in it. I failed it. It was only until I was able to marry it up with something I was very passionate about, which is architecture, that I began to kind of think about how this stuff actually worked. So think about your problems, think about the stuff that interests you, and then see how something like this can weave its way in. Agile, different ways of working, different ways of managing projects, thinking about ways with which you can enable a team to be lean, make decisions fast, and work together as a cohesive unit are increasingly important. We are at a moment where schedules are getting shorter, budgets are getting leaner. We need to be thinking about different ways with which we can operate. Supply chain is going to change. It may not change as fast as someone like me will say it will, but it will change. Part of what's going to be happening with the supply chain of architecture, I think, is that we're going to start to see new models of contracts that go beyond IPD. I'm a part of a project right now where it's designed for manufacturing and assembly on a multi-clinic contract. This stuff is coming into play. I worked with a group in Birmingham, Alabama. I saw they were on the client listing at the very beginning. They have a traditional architectural practice in Birmingham. They have spun off a company called Blocks. They are doing prefabricated patient rooms. They're taking the idea of, they're taking their design know-how and applying it to the assembly line, and they're delivering and installing prefabricated, high-quality patient rooms on site. It's amazing stuff. So for me, there's a lot of hype around this stuff, right? You hear this term, data being described as a new oil for the digital economy. The great thing about data is we're not going to run out of it anytime soon. We're going to be running out of oil. We're not going to be running out of data. But it is something that's fueling business. The thing I encourage everyone to be thinking about is what it means to use data for not just for data's sake, but for performance. And then my encouragement to all of you to go out and prove it. That's it. I have nothing else. Please clap.
So, Nate, this big data, you read about it for every industry right now, right? It's huge from our phones, for the cars we're driving to whatever, not driving. So the one question I have for you is maybe you alluded to this, how do you go about the process of figuring out whether the data is good data? And or how do you also open doors to data that you need, which sometimes you know is out there, but you can't get through the lock?
The question of good data or bad data is the old saying, garbage in, garbage out, remains the same, right? You can pump really bad data in through a really great system, and you're going to get like a really bad product, right? A lot of it comes down to finding people and working with people that you can collaborate with, that you know is going to be able to help you get the insight that you need into those problems, right? we can't know everything by ourselves. So the question of, how do we know if something's good or bad? If it's outside of your expertise, odds are you're going to be able to find someone that will be in their domain, and you find that person and you collaborate. And the same thing goes for the second part of your question.
How do you unlock data?
I think the same thing goes for that. I mean, I hate to go into sales pitch mode or talk a little bit about where or go into sort of like, well, you need to hire someone, because there is an aspect of that. But you want to find people that are going to be ways that are going to help you extend your thinking. Most of our most successful collaborations were ones where we, and myself, in effect, as a consultant in this space, existed side by side with an architect to really work through problems, right? To think about the design in a specific way, where the stuff that I'm bringing in is cross-functional with the stuff that they're thinking about. The other part of it is there are new skill sets in play here, right? To unlock data requires you to understand it. I like databases. I didn't used to like databases. The slides where you saw databases, that's boring stuff. But in order for you to kind of unlock that, you kind of need to understand a little bit about SQL, right? You need to understand a little bit about how the back end of something like Facebook is working, right? So you can start to get into it. Accessing it isn't necessarily the problem if you have someone to help you. The APIs that are out there to allow you to tap into just about any data stream are there. And an API is an application programming interface. So basically it's like a socket on a wall, right? You have all this electricity moving through your walls. You have all these different resources. An API is basically the plug, right? And you just need to make sure you've designed and developed the right input. Yeah.
You mentioned how old designs or old software may modify so that solving problems and new software can be developed. In your research, have you found something that the software can't solve in the world of design?
Can't solve?
Or difficulty in it?
Oh, geez, a lot of stuff it can't solve. I'm not an AI person, like. I don't know. I think we're a ways off before software can actually make design decisions on what it means to have a great experience, right? I'm not going to be one to say like, oh yeah, if we just plug all this criteria into one of our algorithms, out comes a space that people are going to want to be in. That's the thing I think computers are not in a position to solve. Although you talk to some folks at Autodesk, they've got some scary stuff with machine learning that I don't really want to talk about because I don't want to scare anyone. But they're like, oh yeah, eventually the computer is going to be able to make design decisions. That's the one thing I don't buy. I don't think that's going to be happening, and I don't think that it should happen. I think that we ourselves are the ones that are going to be the judge of what ultimately is a good space to be in, what's a pleasing space. And these tools are there to help support all that. Maybe feed you data that you didn't know about that might, this might look like a great space, but maybe the environmental controls are all out of whack. We can use data to start to understand that to make it better. So I think it's about positioning it relative to your intuition. Yeah.
What should architectural curriculum be teaching that they're not teaching?
This one always messes me up. I come from a very traditional architectural education. I didn't know any of this stuff going in. I was always sort of interested in it. I would be interested in seeing an architectural program that's able to form a successful collaboration with the computer science department and have designers and computer scientists working hand in hand on a particular problem. I think it's less about what you should be teaching and more about what kinds of connections and collaborations can you be fostering among other people in the sphere of interest that you're operating in. Biology is the same thing. Architecture and biology, you see, I've seen a couple of interesting programs that marry those two things up. reaching outside the discipline, you know, and not necessarily going outside the discipline where I'm now going to be a biologist or I'm now going to go be a computer scientist, but you know, let's bring these people to the table and find ways within a curriculum that we can allow it to happen. I do think there are some nuts and bolts things like, you know, the grumblings I hear in the profession about, oh, you know, the students that are coming out don't necessarily have the skill sets that we need to make them immediately productive, which I think we should be resisting quite a bit. Like, I always come across like a project manager's like, these students don't know Revit. I'm like, well, okay. They probably know a lot of other things. Maybe you should be tapping into that. Students shouldn't be thought of as like, you know, architectural education should be thought of as like an instrument of production, even though I think that there's some interesting dialogue you could be having there. Maybe there's tie-ins to manufacturing. I'd like to see, you know, curriculums built around thinking about, you know, what does an assembly line really do? And how do products get made? And can that some way inform how you start to think about business models, right? Professional practice could be, now you've got me on a whole other set of topics. Professional practice curriculum. You know, a lot of people, I remember my professional practice curriculum, it was about sitting the NCAR book down in front of everyone and going through, like, here's your black cape, here's your corporate firm, here's all this stuff, and blah, 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 here's your contract documents. That's important stuff. But what about different kinds of practice? And what can we also be learning that have enhanced other industries in terms of business models that we could also be applying to our own? I think there's some interesting dialogue there to be had.
Clarification question on a software that you showed us for a 3D model, specifically the one with the multiple levels and how they relate to the departments on each level. I'm looking at your software online. Do you indicate to which one that is that created?
Which one? It was the.
It was the multiple levels of the building.
Oh, it was like the spider web graph.
Yeah.
That Lunchbox, and then a lot of out-of-the-box Grasshopper. Lunchbox was allowing the user to tap into Excel and bring in a program. There are components inside of Lunchbox that allow you to create queries on a flat data set and create these sort of hierarchies. And then the actual geometry piece was just straight up Grasshopper algorithm, parametric modeling.
Okay, and then I have another follow-up question. I'm kind of curious as to what your pie in the sky vision 20 to 30 years from now, what these tools can do. Kind of, you talked about the workflow and then also tapping into the outcomes. Like, how do you see that playing more of a role into taking those outcomes and making sure we're doing the right thing in the early stages of design?
I try not to project too far out because I always feel like that's going to make me look dumb when someone watches a video like, oh yeah, 30 years from now we're going to be like, drones are going to be laying our bricks. And I think what I would like to see and where I think things need to go, we need to be allocating more time in our business models for research and development in making our process better, right? I used this stat from before, less than 1% industry-wide, right, goes to R&D. Other industries, aerospace, manufacturing, it's 3%. What would it mean to add another percent to the industry when it came to just general process improvement? And we could do that over the next 10 years, the next 3 years, and probably start to see an impact. People are very scared about that though, right? People are scared to kind of take what are already very slim profit margins and apply it to something that may or may not make them better. That's where the risk is. That's where the initial quote is, because that's the way we've always done it, right? But if you were to take a risk, what if there was a value proposition in front of you that if I spent X amount of dollars to build a tool that would take me from, as a project manager, I might be like, the way that I've always done it is going to yield 5% profit on this job 99% of the time, or something like that. But if I invested in this tool that's going to be more cost up front, that might yield me 20% profit 100% of the time. people will see the perceived upfront cost as a risk and see it as, well, I don't even know if it's going to work out, so I'm just spending money. But if you're able to kind of build enlightened project management schemes and think about areas that you can really start to impact a practice, funneling cash towards those ideas, I think, are going to be what really starts to build a groundswell around process improvement. I think we're going to see alignments. I think there's, I can go into some platitudes and some things that you might hear from others. Greater alignments between design and manufacturing, that's going to be a real thing. Your stuff going right into production. But I think the real change is going to come on the business end when we start thinking about, absorbing process improvement into our design practice. You might also see a robot arm that's going to be working side by side with a construction worker on site and like drilling holes into drywall. There's an Autodesk video of that. It's absurd. Don't go. Don't do it.
All right. Well, thank you, Nick.
Thanks.